All right, what we are covering both today and tomorrow, and then again a reminder, Thursday is just review of this first half of Chapter 4, Friday's the summative quiz. We are covering complex numbers, specifically imaginary numbers. So all of the numbers we work with ever are part of the complex number system, and within the number system, a number is either real or it's imaginary, and all of the numbers you've worked with so far in all of your years of math have been real numbers. Just to kind of answer the question right off the bat, why we even cover imaginary numbers if they're imaginary. One, it allows us to solve problems, especially with quadratics, that don't have real solutions. It allows us to still solve those problems, but as we're working with imaginary numbers, we cover processes that we also use with real numbers. So we're going to be simplifying radicals, which you also need to know how to do with a real number, not just an imaginary number. Operations with complex numbers are also used in with real numbers. So all of the math we are doing, yes, the numbers themselves are imaginary, but all of the processes we're using still apply if your numbers are real. So if you kind of look at that aspect, you're still practicing the math, but you need to know how to work with numbers that would be considered imaginary. So ultimately, today you want to be able to perform operations with pure imaginary numbers. All complex numbers can be written in the form a plus b times I. And today we are just focusing on the pure imaginary part of the number, which is the b times I part. So if you think back, after I say this, you might say, oh yeah, that's true. The lowercase I is never used as a variable because I represents the imaginary unit. So if you see I in an expression, it means it's imaginary. And you need to know how I is defined. So it's defined to be the number that when squared, so I squared equals -1. So therefore, if we solved this for I, the number I is the principal square root. That just means it's the positive square root of -1. So I is the square root of -1. So when you get imaginary numbers, you get them from taking square roots of negative numbers. So we know if you try taking the square root of a negative number in your calculator, you get an error. It's because it's imaginary. So these numbers that are listed here, 6i, -2i, I square root 3, these are called pure imaginary numbers because we only have the imaginary part of this complex number form. And pure imaginary numbers, as I said, are square roots of negative and real numbers. And then when this is explained here, the reason they're using b is from this form. So for any positive real number b, if you have the square root of -b squared, that can be split into the square root of b squared times the square root of -1. Since b squared times -1 is -b squared, the square root of b squared is b, the square root of -1 is I, and that's where they're getting the b times I from. So ultimately, knowing that when you have the square root of a negative, that's when you have an imaginary number. So what we're going to look at first is simplifying these expressions, which all of these are square roots of negative numbers, so they're all imaginary. And this is also reviewing then from Algebra 1, and you would have done this maybe a little bit with geometry, because I know you leave certain values or certain numbers in radical form in geometry, but simplifying radicals in general. So remember, when you're simplifying a square root, you cannot have a perfect square factor in the square root. So I do have the first 10 perfect squares on the board. And that means if, say you're looking at 18, if any perfect square is a factor then of 18, so it multiplies into 18, we have to split the square root to simplify it. So when I look at number 1, the first thing I can do when you have a negative square root is split this into the square root of positive 18 times the square root of negative 1. And that's because 18 times negative 1 is negative 18. And the square root of negative 1, that is your I. So ultimately we have the square root of positive 18 times I, or I times the square root of 18. But then you have to determine if you can simplify the square root of 18. So 1 is a perfect square that goes into everything, but is there another perfect square that goes into 18? 9 does. So 18 is 9 times 2. So I can split the square root of 18 into the square root of 9 times the square root of 2. I still have the times I along with it. And the reason you're doing this is then the number that's the perfect square, which is the 9, you can actually take the square root. So the square root of 9 is 3. So I have 3. I leave square root of 2 as the square root of 2. And then I still have times I. And this is your simplified answer. But typically how it would be written is, rather than having the I at the end, it would be written as 3I square root 2. So typically the square roots or the radicals are written at the end. Okay, so again, ultimately, if you have the square root of a negative, you need to know it's imaginary. So you need to take out the square root of negative 1, which is I, and then simplify the positive square root that you're left with. So if we look at example 2, square root of negative 125. So I'm going to skip writing this first step and kind of jump to where I normally go to first. If I have the square root of a negative, my first step is usually to write it this way. I'm going to take that square root of negative 1 out. So I have I times the square root of positive 125. So I'm kind of jumping to this second step I had in example 1. But this is where you're at in terms of being imaginary, and then you just have to determine, can you simplify the square root of 125? So is there a perfect square other than 1 that goes into 125? Grace? 25 does. So 125 is 25 times 5, so it's the square root of 25 times the square root of 5. I still do have the I in front, and then I can take the square root of 25, which is 5. So this is I times 5 times the square root of 5, which I can leave that way, or I can write as 5I square root 5. So you're looking to see, is there, so I have the first 10 perfect squares on the board. 1 goes into everything. But you're looking to see, is there a perfect square that goes into this number? So can you divide 125 by 4? Can you divide it by 9? 16. So it turns out you can divide 125 by 25, and that would get you 5. So 25 times 5 is 125. So you're just splitting it. And why you're doing that is now this is a perfect square factor, so you can take the square root of that number. So you want the number that's in your square root to be as small as possible and not have a perfect square that can go into it. Does that make sense? Does that answer your question? Okay. So I'd like everybody to try number 3 in your groups or on your own. When you're looking for a perfect square factor, this is a hint for number 3. You want the largest perfect square factor. So whatever is left inside of your square root, you don't want another perfect square to be able to go into it. So you want to find the largest perfect square that goes into your number. So try number 3 and then we'll check it. 10 are numbers that I just take the square root of. Because I can't take the square root of 10. So I can, so it's not, then I'm able to take 18. So I'm splitting 18 and then I'm taking the square times this. And then for this one, so I can divide 125 by 25, and it's 25 times 5. That way. And then I can take this. I did like my no. Yeah, I did. Oh wait, I didn't. I got like that stage. Well, you could do it that way. No, what I did was 14. There's only one fully simplified answer.
Okay, one of those squares.
No, that's right. So, right, but it's not simplified because you can still simplify the square root. So don't erase it. What perfect square would be? And this is my first part of it. Well, like, because you take something so you're taking too many square roots. All right, thank you for your patience. I know some of you have been waiting, but just double check. I think we're all okay. There were some good conversations though, because you could split, I need it quiet please. You could split 32 into 16 and 2. 16 is the largest perfect square. If you split it into 4 times 8, the square root of 8 you can still simplify. So realize if you're not picking the largest perfect square, you're just going to have to simplify in multiple steps versus getting this fully simplified answer right away. So as you're practicing those, let me know if you run into any problems or have questions. The next part of this is looking at powers of I, and I did give you for the first 8 powers of I, it's already in this table. You can see what they're all equal to, but I want to go through with you and explain why they are equal to those values. Basically, when you have an expression with I in your answer, if you have I to any power other than 1, so if you have I squared in your answer, I to the 4th in your answer, you can simplify those. You cannot leave I to any power in your answer. The only I you should leave in your answer is I to the 1st power. So looking at powers of I to help explain where these values are coming from, and I'm just going to tell you right now in your minds, be looking for a pattern when we go through these. So we're going to start with I to the 1st power. I is the square root of -1, but it's just I. So you always just leave I as I. It can't be simplified any further. If you have I squared, we know I is the square root of -1. So I squared really represents the square root of -1 squared. What happens when you square a square root? They cancel out, meaning I squared is just -1. So I squared is a real number. It's -1. That means anytime I squared is in your answer, you need to replace it with -1 and then simplify. So you cannot leave I squared in your answer. I cubed. So I'm going to split this. When you multiply terms that have exponents, as long as the bases are the same, remember you add their exponents. So I'm going to split I cubed into I squared times I to the 1st power, because then 2 plus 1 would give you the I cubed. And why I'm doing that then is I squared, we just found that's -1. And then I to the 1st power is just I. And if you have -1 times I, that's -I. So I cubed should never be left in your answer. You can replace it with -I and then simplify from there. And then I to the 4th power, I'm also going to split. I know 2 plus 2 is 4, so I'm going to split this into I squared times I squared. Because we know I squared is -1, so this is really -1 times -1, which is +1. So I to the 4th is +1. Anytime you have I to the 4th in your answer, replace it with 1 and simplify. Okay, so then if we move on to I to the 5th, I'm going to split this. I know 4 plus 1 is 5, so I'm going to split this into I to the 4th times I to the 1st, or just times I. I to the 4th we just said was 1, and 1 times I is just I. So I to the 5th power is the same thing as I. Bless you. I to the 6th power, I'm going to split this into I to the 5th power times I to the 1st power, since 5 plus 1 is 6. I to the 5th power we just said was equal to I. So this becomes just I times I, which I times I is I squared, and I squared is -1. Okay, so you might, at this point, notice a pattern happening. What do you think I to the 7th will equal? Not I. -I, yes. So seeing why that is, I to the 7th would be I to the 6th times I. I to the 6th power is -1, and if we multiply -1 by I, we get -I. What do you think I to the 8th will equal? 1. I to the 8th, I'm going to split this into I to the 4th times I to the 4th, since 4 plus 4 is 8. And I to the 4th is 1, so that's really 1 times 1, which is 1. So, powers of I repeat after every 4. The pattern is I, -1, -I, 1. I, -1, -I, 1. So you either need to know the first 4, know the pattern, or know how to find those first 4, because if you know the first 4 powers of I, you can find any power of I. So this table also lists those first 8 powers. So if we were to extend it, what would I to the 9th power be if we were to keep going? I to the 9th would be I to the 10th would be what? -1. I to the 11th, I to the 12th would be 1, and that just keeps repeating. So looking below, we're going to be going through examples 4, 5, and 6. We're not going to do example 6 first, but just looking below, we have I to the 31st. You can find any power of I if you know that pattern. I, -1, -I, 1. Okay, so that means I to any power other than 1 cannot be left in your answer. It can be simplified. If it's just I, you leave it as I. But if it's I squared, I to the 3rd, I to the 4th, you have to simplify it. So if we look at example 4, we have 3 different expressions for 4, 5, and 6. But example 4, we have -3i times 2i. When you're multiplying these, you multiply them just like you normally would multiply terms together. We can multiply the -3 and the 2. That's -6. And then I times I is I squared. So we get -6i squared. You cannot leave your answer this way because I squared can be simplified. I squared is equal to -1. So this is really -6 times -1, which is +6. So that final answer is a real number. It's +6. All right, and then example 5, we have 2 square roots being multiplied. Now, when you have square roots of negative numbers, that means they are imaginary numbers. And what that means is you cannot multiply the -12 and -2 to get the square root of +24. The only time you can multiply what's in a square root is if they are positive numbers. So what we would have to do first is rewrite these so the square roots are positive, meaning we're writing them in their imaginary form with I. So just like we did for 1, 2, and 3, the square root of -12 would be I times the square root of +12. So I'm taking out that square root of -1 times the square root of -2 is I times the square root of +2. And now that the square roots are both positive, you can multiply the 12 and the 2. And then you also multiply the i's together. So this would be I squared times the square root of 24 And then we just have to simplify if we can. So I squared we know is -1. And then for the square root of 24, is there a perfect square that goes into 24? 4 does. So I can split this into the square root of 4 times the square root of 6. And the square root of 4 is 2. And the 2 and that -1 in front get multiplied. So it's -1 times 2, and then I still have the square root of 6. So it's -2 square root 6. Okay, so ultimately with these, you just have to be very careful with how you're simplifying and know the powers of I as well. And then for number 6, I to the 31st power, what you could do is, we already listed the first 12 powers. You could keep listing until you get to I to the 31st. I wouldn't recommend that, but you could do it. That would just be more time consuming. Another way to do this, there's multiple ways, I'm just going to explain one, is because the pattern repeats every 4, you can take your exponent of 31 and divide it by 4. And now when you divide it by 4, I want you to go back to when you probably first were learning division and you had remainders. So how many times does 4 go into 31? Because the pattern repeats every 4. Once you get to the 4th power, then the pattern starts over. So it goes in 7 times with the remainder of what? 4 times 7 is 28, so the remainder is 3. You still have 3 to get up to 31. The reason you want the remainder is what matters, because this means that I to the 31st power is going to be the same thing as I to the 3rd power. So that's why I was saying if you know the first 4 powers, you can find any power of I. So I know I to the 3rd power then is -I, and that's what I to the 31st power would also equal. So you could list it all out. As long as you, like I said, as long as you know the pattern repeats every 4, you can find any power. Questions on those 3? All right, and then 7 and 8 are very similar. We're just going to go through 7 together, and then we'll get to the homework quiz, because 8 would be solved the same way. Unless you want to solve it, you can always check the answer with me as well. But this is another method you can use to solve quadratic equations. It is review. You did learn this in Algebra 1, the square root property. Some students have already been using it. Instead of factoring differences of squares, it could be used. But what the square root property, or when it can be used, is you still have a quadratic equation. So if you have ax squared plus bx plus c, what I want you to notice, though, for both of the quadratic equations in 7 and 8, is there is no term with just x. There's no bx term. So there's only the x squared term and then the constant term. So the square root property can only be used when you do not have that middle term. If you have the middle term, you cannot use it. And you'll see why when we go through it. So when you're solving using the square root property, you want to first get the x squared by itself. So if we look at 7, I'd want to subtract 108 first. So 6x squared equals -108. And then divide both sides by 6. And -108 divided by 6 would be -18. Once you have the x squared by itself, how do you cancel out a power of 2? You square root. So that's why it's the square root property. You take the square root of each side. That cancels out the power of 2 on the x, so you just have x. Now, when you take the square root of a number, though, you are still going to have 2 answers. When you take the square root, you have a positive answer and a negative answer. So you can write them both together with the plus or minus symbol. So I have plus or minus the square root of negative 18, and then you just have to simplify your square root if you can. So again, what does the square root of a negative mean? How do you make that? Yes. Bless you. So plus or minus, this is I times the square root of positive 18. Now I can't take the square root of 18. I'll get a decimal, but I can simplify it. I know 9 goes into 18. This is the square root of 9 times 2. We actually did this in example 1. And the square root of 9 is 3. So I have x equals plus or minus. I'm going to write the 3 in front of the I. So I have 3i square root 2. So positive 3i square root 2 and negative 3i square root 2 are the two answers. And you can write them together using that plus or minus symbol. Any questions on that one? All right, so on the bottom of your note sheet, there are practice problems I've picked out for this section. It's up to you to actually do it. Let me know if you have questions. I'll have the even answers on the board for those tomorrow. And then you do have a homework quiz, so clear off your desks, spread your desks apart, have them facing forward, please.